Hello and welcome to Math with Mrs. Becker. Today we are looking at Algebra 2 and completing the second part of Chapter 2, Section 3. Linear functions can also be expressed as linear equations in this form, y equals mx plus b. Now hopefully that seems familiar to you. When a linear function is written in this form, it's called slope-intercept form. And that's because you can quickly look at the function and be able to identify the slope as well as what's called the y-intercept. The m is the slope, the b is the y-intercept. Remember, that's the location where your line is going to cross the y-axis. Okay, so one thing that you really want to make sure that you realize is that in this form, y is by itself. So you want y by itself. The value that is connected to x, that is your slope. Remember at the beginning of 2.3, we talked about the slope being rise over run. You can go up and to the right, or you can go down and to the right. Now b, the value after the x, think of it as a starting point. That's your y-intercept. That's where the line will cross the y-axis. So right away, they are going to give you some equations not in the correct form. Your first goal is to write this function in slope-intercept form. So we want the y by itself. So I need to take this negative 4x and I need to move it to the other side. I would have a positive y remaining on this side. If you think of that form y equals mx plus b, the x term comes before the constant. This is a negative 4x. When I move it to the other side of the equation, it is now a positive 4x minus 1. So this is y equals mx plus b. M, the value in front of x is a 4. B, the value after x is a negative 1. Now think of this as a starting point. From the origin, it's minus 1, so I go down 1. That is your y-intercept. Now remember at the beginning of 2.3, we said if you have an m, that is a whole number, okay? Like we have here, 4. You can turn it into a fraction by just putting a 1 under it. That way you know that you're going up 4 to the right 1. And the reason why it's up is because the slope is positive. So I go up 1, 2, 3, 4, go to the right 1. 2 points forms a line. My line isn't very straight. Sorry about that. Connect them and you're done, guys. Let's try another one because this is so fun. Okay. Write this function in slope-intercept form. So what that means is we need y by itself. So I'm going to take this 2x and move it to the other side. Remember, if you have a minus or a negative sign, it's attached to what's behind it. So what I have remaining is a negative y equals, remember, the x term comes before the constant. So now this is a negative 2x, the 9 is positive. I'm not done yet because in slope-intercept form, your y is by itself. This is equivalent to negative 1y. I need to divide every term by negative 1. So negative cancels a negative, so I do have just a positive 1y, and that's what I need. Negative cancels a negative, so this is 2x. Positive divided by a negative is a negative 9. That is your form in y equals mx plus b. Now noticing where I'm going to start here, let's go by 2s. So negative 2, negative 4, negative 6, negative 8, negative 10. Okay. M, the value in front of x is a 2. You can think of that as 2 over 1. To go from one point to the next in this line, we go up 2 to the right 1, up 2 to the right 1. B, our starting point, is after the x, it's a minus 9, so that's negative 9. So from the origin, I go down 9 units. Now if remember, I'm going by 2s. So I go up 2 over 1. 2 points forms a line, and you're done. Let's look at another one. Again, I want y all by itself. Y is here, so anything on the same side as y needs to be moved. So this side is 5x. It's a plus 30 here, so to move it to the other side, I need to minus. This side, what I would have remaining is 15y. Y is not alone yet, so I need to divide everything by this 15 in order to cancel it. So now y is by itself, and I did this one because I want you to realize it's okay for y to be on the left side or the right side. You just need y by itself, okay? Now, if I look at 15 or 5 over 15, sorry about that. If I have 5 over 15, I can reduce that fraction. You can divide both top and bottom by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. It's connected to an x. So I reduce the fraction. Now 30 divided by 15 is 2. So here is your equation. I have had many students in the past who could not leave this in that format. When what I mean is they saw this and they're like, no, y equals 1/3 x minus 2. So if this bugs you and you need to rewrite it, go for it. I have had many students in the past who want that y on the left side, and I get that. But it is important for you to realize that it's okay for it to be on the right side. Okay, so here is our equation, m. M is the value in front of x. It's 1/3. B, the value after x. It's a -2. So to graph it, I start at the origin, and you go to your y-intercept, down 2. Your slope, it's positive, so I go up whatever the numerator is, go to the right whatever the denominator is. Up 1 over 3, 2 points makes a line, and we're done. I hope you guys are enjoying our time together. Let's keep going. So now, just kind of noticing what we've graphed in the previous examples, we had diagonal lines. You won't always have a diagonal line. There are times where your lines will be vertical or horizontal, and that's where we are shifting our focus now. An equation with only one variable, meaning you only have an x or you only have a y, you don't have both, that's when you get a vertical or a horizontal line. If you have x equals a constant, and remember a constant is just a number. If you have x equals a constant, you get a vertical line because it has to cut the x-axis. So if x is your one variable, you are cutting through the x-axis. Remember, the x-axis runs side to side. So in order to cut through it, you need a vertical line. If you have y equals a constant, meaning you just have y equals a number, that's going to be a horizontal line because if y is the variable you have to cut through the y-axis. And remember, the y-axis runs up and down. So in order to cut through it, you would need a horizontal line. Okay, so here, just to make sure that what I just said makes sense and to give you maybe even a better visual, if you have x by itself, it is a vertical line. The reason it's vertical is because you have to cut through the x-axis. If you have y by itself, you have a horizontal line. Okay, so y equals b, you have a horizontal line because it must cut through the y-axis. All right, let's go ahead and do a few of these. So this is x equals 2. So you need to cut the x-axis. Now x runs side to side. If x is positive 2, I'm going to the right 2. I need a line that cuts through the x-axis at that value. If I look at the next one, this is y equals -4. Because it's y, I need to cut through the y-axis. Y runs up and down. This is -4, so I go down 1, 2, 3, 4. There's my point. I need a line that cuts through the y-axis at that point. Let's look at 2 more just to make sure we've got it. Y, so we need to cut the y-axis. Y runs up and down. This is negative, so I go down 1, 2, 3, 4, 5. There's my point. I need to cut the y at that point. So there is y equals -5. Now here, x equals 0.5. Because it's x, I need to cut through the x-axis at 0.5. 0.5 is located in between 0 and 1. So I need to cut the x-axis at that point. And that, my friends, is the end of 2.3. You do have a book assignment for the day. Notice it kind of skips around a lot. I did not want to give you a crazy amount of questions, just enough to make sure that you really understand. So you will start at 13 and go 13 to 20. Then you can go ahead and jump up to 32 to 39, 41 to 46, then 54, 59 to 62. You can find those questions in your textbook on pages 109 to 112. Then please take a picture of your completed assignment and update it to Google Classroom. I'll see you tomorrow.